Students, in this video I will explain you decimal expansion of real number as well as decimal expansion of rational number also, and different cases in which if remainder is 0 or if remainder is repeating, so which type of numbers they are called. Okay, and you can see my previous video also, you can check out, because real number I have already explained, different type of numbers I have explained, so you can check those videos also. Okay, I am explaining you with brown color. So first is decimal expansion of real number. So real number includes rational number as well as irrational number, so we can expand these numbers. So when a real number can be expressed as a decimal, the decimal expansion of real number can be either terminating or non-terminating. Non-terminating, repeating. So what is the meaning of terminating? Terminating means after 2, 3 or after few steps your remainder will become 0. Okay, so if remainder will become 0, then that given number is known as the terminating. Or else if remainder is not 0, then it is known as non-terminating. But if it is non-terminating, then sometimes it may be repeating also, means all full digits they are repeating again and again, they are repeating or they are periodically come again and again. So in that case we will say that these numbers are non-terminating, repeating, or non-terminating, maybe non-repeating also. Okay, so with the help of decimal expansion of real numbers, we can check whether a given number, whether it is a rational or irrational. So decimal expansion of rational number, as we know, q is equals to p by q, where foremost condition for this denominator should not be equals to 0, and p and q they are belong to integers. Okay, so case 1 is when the remainder becomes 0. So on dividing p by q, if remainder becomes 0 after finite number of steps, okay, after finite number of steps, then such decimal expansion is known as terminating decimal expansion. So here we are taking example of 1 divided by 8. So okay, when 1 divided by 8, so here you are seeing this is very easy to divide it. So after 2 or 3 steps you are seeing that we are getting 0.125, and after 125 our remainder will become 0. So since remainder is 0, or after a few steps our remainder will become 0, so we will say that this given number is a terminating, or it is a terminating decimal expansion. Okay, now we are seeing case 2 in which the remainder never becomes 0. Okay, so on dividing, the same process we will do, but after doing division of finite steps, we will see that it is not, our remainder will not 0. Okay, so on dividing p by q, if remainder never becomes 0 and a set of digits repeats periodically. Set of digits repeats periodically means, set of digits means maybe suppose it is 2, 3, 4, 9. Okay, so this we can say that set of digits, and again dividing the number, because we are doing continuously, so we are getting same 2, 3, 4, 9. So we can say that 2, 3, 4, 9 will become set of digits, and again we are getting 2, 3, 4, 9. So they are known as the set of digits repeats periodically. Okay, so on dividing p by q, if remainder never becomes 0 and set of digits repeats periodically, This decimal expansion is known as non-terminating repeating decimal expansion. Okay, and since these digits are repeating, so how we will denote it? So just make a bar over repeating digits. Okay, so since it has bar, so easily checker knows that these digits are repeating. So a block of repeated digits is denoted by bar. So please remember, you have to mention bar over repeating digits. Now we are taking one example, decimal expansion of 8 by 3. So it's very easy. By long division method you can easily divide 8 by 3. So what we are seeing here, we are seeing that 2.666 means, through this we can see easily that we are getting after decimal digit 6 is repeating. Okay, so since 6 is repeating again and again, so put bar over 6. So your answer will become 2.6 bar. So what it shows? It shows that 6 is repeating. Okay, and since here only one digit is repeating, so we are making bar over it. Somewhere you will see that in some books they have mentioned point also. Okay, so if one point over particular digit, so what does it mean? This means that this particular digit is repeating. Okay, or we are getting 2.666 like this. Clear? Now I am taking another example, which is 15 by 7. So 15 by 7 means 7 will divide 15, and you are getting 2.428574. Okay, so by dividing, doing finite steps, we are seeing that our remainder is not 0. Every time we are getting, and after doing finite steps, we are seeing another thing also. What is it? That some set of digits, they are repeating. So what we will see, that 2.142857, this 142857 is repeating again. So since it is repeating again, so we will make a bar over 142857. What this bar shows? Again I am explaining you. This bar shows that next time you will get 142857 again. Okay, so through this we can say that it is a repeating. Okay, now how we can find out length of period? So repeated number of decimal places in a rational number is called the length of period. So here we are saying that 15 by 7 is equals to 2.142857. Okay, and we have already seen that 142857 is repeating, and since it is repeating, so we made bar over it. So how many digits are repeating? So 1 2 3 4 5 6. So since six digits are repeating in this question, so length of period will be 6. Okay, so how we can find out length of period? How many numbers of repeating? Just check. So that will be the length of the period. Okay, so this is all about of this video. Just we will revise it. So how we what we saw in this video, decimal expansion of real number, they are of two types, terminating and non-terminating. Non-terminating may be repeating or non-repeating. Okay, and as you know, rational number can be expressed in the form of p by q, and there are two cases. If remainder becomes 0, then remainder will become 0, then we will say those numbers are terminating decimal, terminating, or it is a terminating decimal expansion. And if remainder never becomes 0, then some digits are repeating, so we will say that we will make over bar or we will make over dot, so that easily checker will know that this many numbers are repeating. And how we will find the length of the period? So just by checking number of digits which are repeating, that will give the length of period. Okay, so this is all about of this video. Hope this video will help you. Thank you.